Okay, so now we're going to go through some metal finishes and design techniques is on there as well. So we usually include a finish to metal to preserve it for as long as possible. The most common ways of preserving metal are the following. So you've got plastic dip coating, polishing, paint finish, lacquered finish, and also galvanizing. So we're going to start with plastic dip coating, something that we have covered in the past. So plastic dip coating is a process that involves immersing a preheated part of metal into liquid plastic. This forms a plastic coat around the metal, which improves its protection and aesthetics. So that's just a piece of metal going into liquid plastic. When you pull it out, you've got that protective layer around it. Galvanizing, very similar technique to plastic dip coating, but instead of dipping it into liquid plastic, you dip it into zinc. So galvanizing is a manufacturing process where a coating of zinc is applied to steel or iron to offer protection and prevent rusting. This is a similar process to plastic dip coating, but with molten zinc. And you can see a couple of pictures there. When you've got that kind of animal print texture to it, you can tell that it has been galvanized. A lot of handrails on the outside, buckets, pipes and so on. Cars are now also galvanized to stop them from rusting. Next one, we've got polishing. Protects it to sort of, but really there to get rid of scratches and dirt from the metal. So the polishing machine or buffing machine is used to polish soft metals as well as plastics. Polish is applied to the mop of the polishing machine that then rotates and removes dirt and light scratches from the metal. Once you have polished it, you can then add further protection by lacquering the metal. So a lot of brass ornaments are lacquered. So lacquer is used on brass ornaments and finely machined steel. Lacquer is usually applied to metal after polishing to further protect the metal. So it comes out like liquid, sprays on, and then solidifies over there. It leaves a clear film on there. You don't see it, and it is a plastic substance. Here as well, we've got the easiest one. So paint and spray paint finishes. Paint and spray paints in the form of spray cans can be bought straight off the shelf of most hardware stores. So that's B&Q, Screwfix and so on. The paint provides a layer of protection for the metal which is required for metal items that are left or placed outside. And just on the right hand side here, you can see somebody spray painting a fence. Again, exam style questions popping up. Most bikes are made using ferrous or non-ferrous metals. Explain what is meant by the term ferrous and non-ferrous. Provide one advantage and one disadvantage of manufacturing the bike out of ferrous and non-ferrous metals. And then copy the following table into your books and fill in the blanks. So if you'd like to do these questions, please pause the video and answer them fully. Okay, moving on to destructive and non-destructive testing. So testing materials. The main role of an engineer is to develop solutions to problems by using materials to create objects, items and products that would solve those problems. A typical problem that an engineer could be asked to solve is how can we cross this river? So destructive testing, when you want to find out the limits of the material you will be using, you will usually test the material to destruction. Non-destructive testing does not destroy the material or product during testing, but still provides properties of materials whilst performing a function. There are many situations where destroying the product by testing is either too costly or too unrealistic. So firstly, a non-destructive test is using computer-aided design. So it's not just there to design products, it's also there to test products. So modern engineering are required to use CAD software to create, develop and test design solutions. This type of virtual testing is called finite element analysis, FEA. Using FEA then allows to design their solutions with FOS, so that's factor of safety. For example, if an engineer is tasked to design a bike frame that could hold a person weighing 200 kg, a CAD test would be carried out to see what thickness would the bike frame break under 200 kg. The engineer would then take extra safety precautions by using the bike, by ensuring the bike could withstand more weight than needed. This is often known as factor of safety. If the design bike would be given an FOS of 2, this thicker frame would be able to withstand 400 kg instead of just 200 kg. So testing for tensile strength, so how well a material retains its strength when being stretched without permanently deforming or breaking. There is a simple test for this, which you can see at the bottom. I am not going to go through all of these testings because you have it in your PowerPoint, and there are a few questions at the end for you to look through these types of testing for strength and so on for you to answer that. So testing for hardness, the ability of a material to resist scratching, cutting, wear and tear. Testing for toughness, the ability of a material to not break when deformed and to absorb energy without fracturing. Testing for malleability, the ability of a material to be pressed, spread out or hammered with relative ease. Testing for ductility, the ability of a material to be stretched and deformed without breaking or fracturing. Testing for conductivity, so this is electrical conductivity, the ability of a material to transmit or conduct an electrical current without encountering too much resistance. Testing for conductivity again, however, this is thermal, the ability and rate at which a material can conduct or transfer heat. Testing for elasticity, the ability of a material to regain its original shape once it has been stretched and deformed. Next, we've got some exam style questions, very similar to what pops up in the mocks or your exams in the exam in the future. So I've got a few here for you to do. So I've got 3 in total. A sea fishing rod will endure high levels of tension when a large fish is caught. It's vital that the fishing rod doesn't misshape or break during the catch. Using notes and sketches, and that's really important that you understand that notes and sketches will get you the marks. Describe a tensile test that could be performed on a fishing rod. So at the bottom there, you've got notes, that gives you 3 marks, and the sketching gives you 3 marks as well. Remember to annotate your sketching, that will get you marks. Just sketching without without putting any annotation around it won't get you many marks. So there's a little clue for you. Next, I've got, it's important that a refuse skip does not break when used and to absorb energy without fracturing. Using notes and sketches, describe a test for toughness that could be performed on a skip. Again, notes 3 marks, sketching 3 marks, and a little hint there for you. So we go through our PowerPoint, go through this video to find this, and it will tell you a test to put on the skip there. And finally, the popular Stretch Armstrong toy from the 1970s is being redeveloped and is set to be sold in 2025. The development of materials over the years has enabled Mr. Armstrong to be stretched further than ever before. Very exciting. Before its release, an elasticity test must take place. Using notes and sketches, describe a test for elasticity that could be performed on a Mr. Armstrong toy. Notes again, 3 marks, sketching 3 marks, and a little hint here for you.